Hello viewers, welcome back. In this video lecture we are going to talk about the acidity of phenol. Before start this topic, we should understand certain general terms. The nature of the substance like acidity or basicity and its strength of acid or strength of base is a relative term. First we should understand it, that nature and its strength is a relative term. On that basis, here there are two important criteria. As we know, if we do any reaction like any acid base, so this is H, this is an acid, and this is a base. If in any acid base reaction, so we can get this is a conjugate acid and conjugate a base. Okay, so we will get it like this, and in this equation the strength of the acid or base can be compared with the opponent one. For example, if we consider the strength of the acid, if it is a weaker, that means the conjugate base is strong, okay, or vice versa. Or I will repeat it again in other way. You take some example. If the conjugate acid, this is BH, if we say it is a stronger, that means that opposite one, the base is a weaker. Okay, so likewise we can understand it. Okay, it could be vice versa. One is stronger means the opponent side should be a weaker. This is the first criteria. And the second one, there are certain groups can increase the acidity and basicity. Now you see, the electron withdrawing group always increase the acidity. That means the basicity, the electron withdrawing groups will decrease the basicity. Okay, the electron donating groups will decrease the acidity and it will increase the basicity. So these two are the important key points we should remember, that acid and base gives conjugate acid and conjugate base, and the strength can be compared. And another parameter is the donating groups, that is electron donating groups and electron withdrawing groups. The electron withdrawing groups always increase the acidity, so electron donating groups increase the basicity. Okay, with this fundamental, now we are going to discuss the acidity of phenol. The phenol is having OH group and the alcohol also having OH group, but the phenol is comparatively higher acidic than alcohol, for example ethanol. Now how we can conclude this hypothesis? Now let us take this reaction. This ethanol reacts with sodium hydroxide, form sodium ethoxide and water, and similarly this phenol reacts with sodium hydroxide and forms sodium phenoxide and water. Now let me see this one, the phenoxide ion stability. Now we are going to discuss about the phenoxide ion stability. This is the phenoxide ion. This phenoxide ion is mostly stable than ethoxide ion. For example, here it will undergo the resonance, for example like this. So you know this, how to rotate the electrons in the sequential manner. Okay, so like this, and again you have to rotate like this. You can draw the resonance structure. So it forms like this, and you see you have to carefully assign the charges, and you can draw like this. So you will get this kind of a resonance. Okay, so now you see it in the phenoxide ion, the negative charge is completely distributed over the structure. Okay, so that's why the phenoxide ion is more stable, and as a result what will happen, the phenoxide ion and behave as is behaving as a weaker base. Okay, so that means here this phenoxide ion is a conjugate base, and this is phenol is, now we consider it's an acid, and this is a base, sodium hydroxide. Now this phenoxide ion is behaving as a weaker base, because the reason is this negative charge is getting delocalized and it is spreaded over the complete molecule. But if you see the ethoxide ion, there is no delocalization of the pi electrons or the extra negative charges. That's due to that reason this became a strong base. Okay, if this is a strong base, this is a conjugate base. Okay, here in this reaction ethoxide is a conjugate base and this is a base, sodium hydroxide, and here alcohol is an acid. If the conjugate base is stronger, then automatically that acid should be weaker. Here phenoxide ion is a weaker one, then definitely their acid will be a stronger. This phenol is stronger. That's the reason the phenol is highly strong acid than alcohol. Okay, due to the resonance of the phenoxide ion. Now let's discuss one more important point, how the substituent in the phenol will increase or decrease the acidity. As we discussed, the electron withdrawing group will increase the acidity and electron donating groups will decrease the acidity. Now I will show you some examples. You see here that nitro groups are electron withdrawing groups that we discussed already, and here there are nitro groups, and this methyl group is an electron donating groups. When the electron donating group is present, you see that pK value, the acidity, that higher pK value means that is a weak acid. That lower pK value is a strong acid. You see in the 2,4-dinitrophenol there are two nitro groups. You see the pK value is 4.09. When you are increasing the nitro group, you see 2,4,6-trinitrophenol, that is picric acid, you see the pK values become lower. That means the lower pK value is highly acidic. So it clearly, and that explains that electron withdrawing groups increase the acidity and electron donating groups decreases the acidity. I hope you understand this lecture. Kindly subscribe and share it if this video lecture is useful. Thank you.